Alrighty, guys. Welcome back to Mr. Moore's Algebra 1 and 2 class. Today we're going to talk about 2-4, more about linear equations. This will be the last section that we're going to learn for this first quarter. Okay? You're going to have a test on 2-1 to 2-4 on Thursday. Now, there are three forms of linear equations. Okay? You have the slope-intercept form where y is the independent, we know that. M is the slope, that's rise over run, we know that. X is independent, we know that. And B is your y-intercept, we know that. Okay, we have already worked all of that. Sorry, that's dependent for y. Thank you for catching that mistake, son. Y is dependent, X is independent. Thank you. Now, point slope form. This is really what we're really going to work with today, and that's the really good equation here. This is the easiest one to calculate stuff. What does this tell you? It says y minus y1 equals m times x minus x1, where m is the slope. Either they give it to you or they give you two ordered pairs and you can find the slope. And the x1 comma y1, that will be given to you. And we're going to learn how to work that in a second. And then you have standard form, which is ax plus by equals c, where a and b are integers. Okay, they're not fractions or decimals, they're integers. We're going to work with standard form a little bit today as well. It's very simple, not very useful except for just a couple things, and we're going to touch on those right now in a second. Now it says that we have already learned how to work with a slope-intercept form, which is by far the best form to use when graphing a linear equation. If you're going to graph, that's the best way to do it. Today, we will learn how to use the point slope form, which is the best form to use when writing a linear equation. Okay? And from the point slope form, we easily go to the slope-intercept form. So we use the easiest way to write the equation, then we transfer that to the easiest way to graph that equation. Very good. So here we're writing an equation, and the standard form, we're going to learn that, which is the best way to graph a linear equation using x and y intercepts. So that's what we're doing today. All right, point slope form. This is y minus y1 equals m times x minus x1, where x1, y1 are given. Since you will always be given either a slope and 1 point, they're always going to give you either a slope and 1 point, or 2 points which can render the slope and 1 point. Always use the point slope form of linear equations to write linear equations. Let me explain how this works, my brothers. Example number 1. A line passes through -5, 2 with a slope of 3/5. Write the equation of the line in slope-intercept form. Now, some of you may say, wait a second, okay, hold on, Mr. Moore. You want us to write it in slope-intercept form. I have an x, I have a y, I have a slope. Why can't I just plug it in and solve for the y-intercept? You can. What I just said was, remember you have y equals mx plus b, right? So you could plug in the 2 for the y, the m for the 3/5 for the m, the x is -5, and then the b, right? And then you would have to solve for b. You with me, guys? So that would cancel, so that would be -3. You add 3 to both sides, and then b would be 5, and then you would rewrite it as y equals mx plus b. That's what we learned last week, didn't we? Hello? Okay. We can do that. You can. If you don't like what I'm about to teach you, you can use this. But take it from me. Excuse me. I used to be one of those guys that loved the slope-intercept form. I thought that was the only way. That was the best way. I didn't like the point slope form. Forget it. My teachers are stupid. I didn't click till later on that what I'm about to teach you now is superior. Absolutely superior. And it's needed. Sometimes on the SAT they'll say, write the following equation in point slope form. And that's it. They only want you to do it in point slope form. In that case, if you don't know what I'm about to teach you, you're going to get hurt. So, get to it already, Mr. Morrow. You know that they gave you a slope. You know they gave you an x1 and a y1. So step 1, find the slope and label the given x1, y1. I already did that. The slope is 3/5. They told you in this particular case. And the line passes through -5, 2. That's the point, the given point that they gave you. If they gave me 2 ordered pairs, how would I find the slope then? There you go. Thank you. Thank you, son. You plug it into the slope formula. y2 minus y1 over x2 minus x1. And then I could either use x1, y1 or x2, y2 to plug into the formula. Number 2. Plug in the slope and the x1, y1 into the point slope form. And you're done. The equation is now in point slope form. In order to convert the equation into slope-intercept form, simply solve for y so as to it in what? Solve for y so as to put it in y equals mx plus b form. Now, what is this crazy man talking about? Check it out, boys. So y minus y1 equals m times x minus x1. So I have y minus, what's my y1? So minus 2 equals m. What's my slope? 3/5 times x minus x1, which will be negative minus the -5, so that'll be plus 5. Is everyone with me so far? If they ask you for this in point slope form, I swear you're done. I promise. That is point, I don't know how to spell today. That is point slope form. Now, they asked you, though, to put this in slope-intercept form. I'm going to always ask you pretty much to graph it. So regardless, you're going to have to put in slope-intercept form. Now, this is the easy part, okay? We know how to solve for y here. Let's distribute the 3/5 x. So isn't this going to leave me with y minus 2 equals 3/5 x plus 3? You see that, guys, because I distributed? My brothers? And then I add 2 to both sides. So then I have y equals 3/5 x plus 5. That's my slope-intercept form. Now from there, I can graph this bad boy really easily. Really easily. Let me shrink this down a little bit. All right, check it out. What's my y-intercept? 5. So 1, 2, 3, 4, 5. What's my slope? So rise of 3, run of 5. Up, 1, 2, 3, run to the right, 1, 2, 3, 4, 5. I don't have any more space, and I'm just going to go backwards. So when I go backwards, I go down 1, 2, 3, to the left, 1, 2, 3, 4, 5. Remember, you always run to the right unless going backwards. You always run your slope to the right unless going backwards. Does that make sense so far, gentlemen? Pretty simple, right? Okay. Now, what happens here? A line passes through 3, 2, and 5, 8. What is an equation of the line in both point slope form and slope-intercept form? Okay. What did we say step 1 was? Find slope. Very good, gentlemen. So in this case, we don't have the slope ready for us. So we're going to go ahead and label x1, y1, x2, y2. And we're going to find our slope of y2 minus y1 over x2 minus x1. That's going to be 6 over 2, which in this case is 3. That equals my slope. Now, step 2, we plug in the slope and the x1, y1 into the slope into the point slope form. So y minus y1. What's y1 here? 2. Could I have chosen 5/8 as x1, y1? Yes, you could have. Once you choose one, though, stick with it, please. So y minus y1, which is 2, equals m of 3 times x minus x1, which is also 3. That's it for the first part. That is your point slope form. You are done as far as point slope form is concerned. But now, unfortunately, they want it in slope-intercept form. Okay? So that's the first part. But now I got to solve for y. So it's going to be 3x minus 9. Add 2 to both sides. Y equals 3x minus 7. That's slope-intercept form. And hopefully you guys are realizing, hey, Mr. Mole's right. Point slope form is the bomb for writing it. But then when I want to graph it, it's slope-intercept form that really works. Boys, that makes sense. Promise? Sir? Okay, well, that was what I just asked before. Could I have made this x1 and y1 and that x2 and y2? Yes, but, I mean, I'm not trying to be a jerk, but why would you? First point you see, make your life easy, x1, y1. Second point you see, make your life easy, x2, y2. Does that make sense, son? Thank you for your honesty, brother. Okay, now, standard form. Standard form, sometimes you will be asked to convert a linear equation into standard form. Simply manipulate the equation, excuse me, so as to put the x and the y together. Okay, sorry about that. So, like I was saying, standard form. Sometimes they're going to ask you for standard form. And standard form is useful, okay, when they're giving you x and y intercepts. Now, what are x and y intercepts? We've talked about the y-intercept, but let me just talk about intercepts in general. The x-intercept is the x value when y is 0, and it's on the x-axis. And the y-intercept is the y value when x is 0 on the y-axis. Okay? Now, how does this work? Great, Mr. Moore. Whoop-de-doo. What do we do with it? Let me show you. What is an equation of the line y equals 3/4 x minus 5 in standard form? Okay. Use integer coefficients. So I got y equals 3/4 x minus 5. All right, guys. I want to get the x and the y's together, but I only want integers. So can I work with this fraction first of all? How do we get rid of that fraction, my brothers? Fantastic. Thank you, guys. So I got 4y equals, distribute, 3x minus 20. You guys with me? Now I subtract 3x to both sides. And I got negative 3x plus 4y equals negative 20. Now, even though they said use integers, sometimes, not me, but the SAT will sometimes be a little picky about this. You can have this in this format, but sometimes they want the x positive. So if they want the x positive, wouldn't you just divide everything by a negative 1? So if you did that, you would have then 3x minus 4y equals positive 20. For Mr. Morrow, I don't care. I do care that they have to be integers, but you can give me either or, and I will be fine with that, gentlemen. Does that make sense, gentlemen? So getting into standard form, I want the x and the y's together on one side, and I want the coefficient of the x and the y's to be integers. Okay? That makes sense, guys? You good? Okay. Now, what are the intercepts of 3x plus 5y equals 15? Then graph the equation. Okay, this is good. Could you go ahead and solve for y here, put it in slope-intercept form, and graph? Yes, you can. Now, I would do that unless the following happens. Do you guys notice that the coefficient of both x and y are factors of the constant? So basically, if the coefficient of x and the coefficient of y can evenly go into the constant, you use this method, and it's called graphing by x and y intercepts. What would the x-intercept here, guys, be? X-intercept, remember, is the x value when y is 0. So if y was 0, wouldn't this be 3x equals 15? So x would equal 5. So my y-intercept is 5, 0. It's the x value when y is 0. What about my y-intercept, my brothers? For the y-intercept, I'm going to make x 0, right? So in this case, divide by 5. So y would equal 3. So the y-intercept would be 0, 3. It's the y value when x is 0. Do you guys see that? Now look how beautiful this is. Let's graph both the x and y-intercept. 1, 2, 3, 4, 5, 0. 1, 2, 3, 0, 3. Boom, you're done. Have a good day. God bless you. Bye-bye. This only works, though, when the coefficient of x and the coefficient of y evenly go into the constant. Excuse me, brothers. Does that make sense? Yes, sir, my brother. Okay, the question was, we don't have to use it. No, but with all due respect, you'd be a fool not to. Let me show you what I mean, Danny. Okay, this is all on video, so you guys can pause that and rewrite it if you want. Just real quick, bro, because I appreciate what you're saying. A lot of times, like me, I was stuck on, no, slope-intercept, 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 slope-intercept. I like slope-intercept. I want to do everything slope-intercept. And you got to be versatile. What if I gave you this, bro? 4x plus whatever, 16y, come on, moral. 16y equals negative 32. Whatever I see an equation in standard form, I simply ask myself, hold on. All right, so let me continue here, guys. For this particular example, someone was asking me, can't I just do the slope-intercept method? You can. You can. I swear you can. But why would you? 4 goes into negative 32 and so does 16. So in my opinion, guys, what I would do is, okay, when x is 0, I'm going to first find the y-intercept. Wouldn't the y-intercept basically be 16y equals negative 32? So y equals negative 2? Guys, you see that? Because I made x 0. And then x-intercept, I'm going to make y 0. So 4x equals negative 32. So x would equal negative 8. So my y-intercept is 0, negative 2. My x-intercept is negative 8, 0. 0, negative 2, boom. 0, negative 8, 0, boom. Connect the dots. So the answer to your question, you can do it the way you want to do it, the long way. But I strongly suggest to do it this way. Yes, sir. This way it's a lot quicker, yes, sir. And it also gives you command of the fact that you know how to find the x and the y intercepts, which are really important, brother. Thank you. Yes, sir. What, buddy? You don't need the slope here in this particular case. You just graph the x-intercept and the y-intercept. Now, if I said from here, how do I find slope? Don't I go from one perfect point to another perfect point? So in this case, I'd go up 2 over 1, 2, 3, 4, 5, 6, 7, 8. So in this case, the slope would be 1/4 if I ask for that. Does that make sense, though, Pablo? Thank you, my brother. Okay, now, two last things. I know the bell's going to ring. I know you guys work hard. I know I'm a pain. I want to thank you ahead of time right now. I'm going to keep you here a couple extra minutes, okay, guys? I'm going to do it as fast as I can, but I want to make sure you understand this. Please and thank you. Parallel lines. Parallel lines have equal slopes. Remember that. Equal slopes. Equal slopes. Parallel lines have equal slopes. Since they have equal slopes, the lines will never intersect. If you can see this here, guys, this line is y equals 3x plus 8. This is y equals 3x minus 4. When the slopes are the same and the y-intercepts are different, they are called parallel lines, and they will never intersect. So the slopes, 3, 3, the slopes are the same. So when you have parallel lines, the slopes are the same. You have all of this on your sheet. When the slopes are the same, you have parallel lines. Perpendicular lines have slopes that are negative reciprocals of each other. Since their slopes are negative reciprocals of each other, the lines will intersect at one point and they are perpendicular. If you notice here, where the lines intersect, you have that little box. You know that box is a 90-degree angle. Now, the slope for this guy is negative 1/3. Slope for this guy is 3. Those are negative reciprocals. To get a negative reciprocal, you multiply the original number by negative 1 and then flip it. So for example, here's original, here's the negative reciprocal. Sorry about that loud beep that you just heard in the video. Original, let's say my number was 5. The negative reciprocal would be negative 1/5. If my original number was 3/2, my negative reciprocal will be negative 2/3. If I have 1/5 as my original, the negative reciprocal will be negative 5. You multiply the original number by negative 1 and flip it. Does that make sense? Sir? You sure? Okay. Now, what is all this stuff for? Last thing. How to write equations for lines that are parallel or perpendicular to a given linear equation or graph, going through a particular ordered pair, x1, y1. First thing you want to do, all of this is already on your paper, guys. Find the original slope of the given equation. 2, find the parallel or perpendicular slope of the given equation, depending on what you're looking for. If they're asking for parallel, then you're going to look for the parallel. If you're looking for perpendicular, then you're looking for the negative reciprocal. Plug in the given point x1, y1 and the new parallel or perpendicular slope into the point slope form. Remember point slope form? It helps us remember right equations. We're going to use the same thing here. Then at the end, solve for y in slope-intercept form, y equals mx plus b. Let me show you how this works, and it is easy, I swear. They want you to write an equation of each line in slope-intercept form, which is A, parallel to y equals 6x minus 2, and going through 1 comma negative 3. Let me just, if I had it like this, you guys know that you have to first solve for y, right? To get into slope-intercept form. Now, let's go by my rules. What's the original slope? Original slope is 6. Are we looking for a parallel or perpendicular slope? So what's that symbol's parallel? What's my parallel slope?
6.
Now, step 3, let's plug the sucker in. Y minus y1 equals m times x minus x1. Now I want this in slope-intercept form though. So this is y plus 3 equals 6x minus 6. Subtract 3 to both sides. Y equals 6x minus 9. I have the slopes, which are the same, and I have different y-intercepts. When I have lines with the same slope and different y-intercepts, they are parallel. Now be honest, wasn't that just like writing a regular equation? The only difference is determining what the parallel or perpendicular slope is. Last but not least, and I promise I'll let you go. You guys have been super, super, super patient. I want to graph a line now, write an equation that is perpendicular to y equals negative 4x plus 5 and going through 8, 5. So, step 1, what's my original slope? Original slope is negative 4. Okay, what's the perpendicular slope now? The negative reciprocal. Multiply that by 1 and flip it. Great job. Step 3, plug it into slope in a point slope form. Y minus y1 equals m times x minus x1. Remember, you're using the new perpendicular slope. So now, y minus 5 equals 1/4 x minus 2. Add the 5 to both sides. Y equals 1/4 x plus 3. Ding dong, the witch is gone. Does that make sense, guys? You guys rule. Thank you so very much. Homework is valid. God bless you. Have a great day. Bye-bye.